Hello everyone, welcome to the fourth module of the Fundamentals course here at Code at GWA. Today we're talking about conditionals. This is actually the first part of conditionals. Since it's quite an involved concept, we decided to break it apart into multiple modules. Okay, so before we get right into conditionals, let's talk a little bit about Booleans. So like I mentioned in module 2, Booleans are a very simple data type which can hold two values, whether that's true or false. And in Python, we capitalize the words true and false. This may be different compared to other programming languages. Okay, so getting right into the main concept, the if keyword in Python. So the word if in Python expects a statement afterwards, which if that statement resolves to be true, it executes the code underneath that statement or nested within that statement. Additionally, if that statement is not met or if that statement is not true, it executes whatever is under the else keyword right here. So let's see an example of this. So this is an extremely simple if statement. We literally have if, and we've explicitly written our condition, which is true. So regardless of anything, this will always default to true. And just one thing, if you see this warning, you can hit run anyway. This is just to protect external notebooks from running on your machine. We have moderated every single notebook, so please do not be worried about running these. Okay, so like I said, if this is true, this code block is, or the code nested within this is executed, and we can clearly see that here. Okay, so instead of explicitly declaring true or false, because this is kind of useless because we can literally just write this, you can set a variable to be the statement. So here we have a variable called hot t, and that's a Boolean actually, which is set to be true. So again, if we run this, you can see that this code nested underneath this statement gets executed because hot t is true. And if we make this false, you can see that this line will be printed because this condition is not met. Additionally, you can use pass if you still want to keep the else keyword and you don't want to do anything. So if I were to run this, it's not going to do anything because this variable is set to false and it's checking if this variable is true. It's not true, so it goes to else. And else just contains the pass keyword, which just tells the compiler to just skip over and do nothing. Okay, so moving into task 1, this is a very simple task. We simply have to check the condition of this variable and print an output. So if it's sunny today, we will have to print that it's sunny today. And this is what's sort of nice about Python is that as you describe it, you can actually code it. So our first line, very similar to this line up here, will just be if sunny today. And then we put a semicolon after this to indicate that the next line will in fact be indented or nested. You can see that the cursor is not over here, it's over here. And that's a very important thing in Python because we don't have curly braces, so the white space in your code matters. So that depends whether it's nested or not. And within this, we can just have a simple print statement like so. Very simple to that up there. And now we also have to use the else keyword, so we'll simply populate the code cell like this. Just to note, when you hit enter, you will be in this line. However, because the else is not within the if, we'll have to move to the left by 1, and then we write this right here. And make sure that this is actually indented after else. What's nice about modern IDEs is that if your cursor is there and you hit enter, it automatically indents your line for you. So if we run this, similar to the thing above, this code block should run, and it's saying it's sunny today. So let's try the other conditions. Let's set this to false and run that again. So I'm just going to copy this over here and paste it into here. It says it's not sunny because this condition is not met, and it simply skips over to here. Okay, so let's move on to some examples. So I'll run the first code cell here and talk about it. So it says enter the title of a favorite book. Let's say The City of Ember. Okay, and then and it returns a print statement that has the thing we entered, and it says nice capitalization in that title. This simply uses the isTitle Boolean string test. So we literally have a variable that that calls the input method. If you don't know what that is, again, please go to module 2. And it checks if that string is formatted as a title. So this part returns, so if that resolves to be true, it executes this, right? So because I formatted it correctly, this code block is executed. So let's try the other case. Let's not format it correctly. As you can see, this is extremely poor formatting, and if I run this, this is not true, so then it skips to else, and it says consider capitalization for book titles. Same concept here. If I run this, it basically checks if it's a digit or not. So for example, if I put, I don't know, WASD, it says it's not a positive integer. And this actually goes one step further, and it asks if it's an alphabet, it says that it's more like a word. So this is an example of multiple if statements being used in one code cell. Again, it leverages these Boolean string test methods. Okay, so this is a more advanced version. We can see that it's the exact same concept. However, the condition is a lot more complex because we have a variable that's being changed, and we have another function that runs on the changed variable. So let's run this and show you. So it says enter a vehicle that starts with P. In this, we can actually use any case we want because it says vehicle type dot upper. And if you remember from, I think, module 2 again, dot upper, all it does is that it formats the string so that all the letters are uppercase. So let's try this out. So here it says that Prius starts with P. Let's try another case. Let's try, I don't know, Model 3, for example. That's a personal favorite. It does not start with P. And you can see that regardless of the case we use, so let's put PRIUS like that, it should still say starts with P because here we can, because here it's always being made to upper. So yeah. And because of that, we can use the starts with P capital. So make sure you keep that in mind if the if statements that you write do not work as intended. Okay, so moving on to task 2, which is evaluating Boolean conditionals. For this, we simply use these functions up here. So this is quite a straightforward task. So basically what we do is, it says we have to check the condition for both of these if both the strings are lower. So first we start by checking the very first string by using these functions up here. Now that only tests the first string, right? So we have to test the second one as well. So if this passes, we do the next test, which is to test if the second one is lowercase. And if both are lowercase, we can simply have a print statement that says both are lowercase, like so. And if at any point it fails, we have an else statement right here, and then we can just print something back to the user, they aren't lowercase. So let's run this and check it out. Here we can see that they aren't lowercase. Notice how I had to move the else into here because what was happening was this was correct, so the else on this side was not being called, so we had to nest the else outside. If you're because of that, we have to add another else over here, which also says the same thing. Because we need to report that for both strings. Okay, so moving on to task 3.1, where we basically have to create a function that checks for a specific letter within a string. So this extends off of what you guys learned in module 3, which is where we were talking about user-defined functions. Okay, so first let's start populating our strings. So because we're checking if a W is there, my first string will not contain a W and my second string will contain a W. I've just put my name for the first one. I've put Wario for the second one. And for the third one, let's put, I don't know, John. Now our first thing is to create a function. So if you remember from module 3, we used the def keyword in Python, and we type the name of our function, which is going to be starts with W, as mentioned in the directions. And we're actually going to pass a parameter into the function called input, which is a string that is checking for against the W letter. So because our input is a string, we can use the above functions right here to run tests on it. So we'll use the if input, and this input refers to any string that we pass as an argument into the function. So if that input starts with W, that's going to be our conditional. And if it does start with a W, we're simply going to return true. And if it does not, we're going to return false. Okay, so that's our function done. And now we have to test the 3 string variables provided by calling the function. So let's test the first one. So let's do starts with W, and then we'll do test string 1. So this does not, so this should return false. Yep. And let's actually test multiple at one time. So because of the, this only works because Google Colab, it basically writes out the return of a function if there's a singular function on the end of the code cell. However, since we want to test out multiple, we have to put print in front of it. So basically all we're doing is we're passing the output of starts with W function to the print function, which allows us to see what the function has outputted. So let's test all of these. These should be false, true, false, because there's no W there, there's a W there, and there's no W there. And we get what we expected. Okay, so task 3.2 is very similar to task 3.1. So in the interest of time, I'm not going to bother explaining it. Again, if you guys have questions specific to this or anything, do not hesitate to email us. As always, our emails are down in the description below. Okay, so if you have understood what we've done so far, pat yourself on the back. We understand that we're going quite quick, and these are new concepts for some of you guys. So, great job. Okay, so now we'll be moving into comparison operators. So until now, we've simply been using the built-in functions like this to return a true or false. However, now we'll start making our own comparisons using the mathematical symbols. So these two are pretty self-explanatory. These are if you want to include equal to within the greater or less than. And the double equal to checks if a certain variable is the same as another variable. Don't confuse this with the single equal to sign, which is used to assign a specific piece of data to a variable. So there's an example. So these are just simple mathematical statements, and we can see that if you were to write them out in code, it would actually output a Boolean based on the condition. So because 3 is not greater than 5, it outputs a false. And because 3 is greater or less than or equal to 5, that's true. So all this tells you is that if you were to write a mathematical comparison like that, the result of that comparison would be outputted basically. Right, so this is so this just uses the more advanced exclamation not operator. All it does is just not equal to, so it checks if something is not equal to. Because x is not equal to 9, that statement returns true. Okay, so moving on to task 4. This is very simple. It's just like what we have up here. We just have to print if x is equal to 13 or not. So we're just going to use something similar to up here. Notice they're using the comma formatting. This is the preferred way to do things. So we'll just have a string is x equal to 13, and we'll use the mathematical comparison right here. So as up here, because x is equal, because 9 plus 4 is equal to 13, this statement resolves to be true. So we have true. That's written out to the console. Okay, so the next one is a little more involved. We're basically gathering an input from the user, and based on that input, we are sending the user back something. So for the first part, we have to gather a number from the user, so we're going to use the input method. Next, we have to make an if statement. So this is how you make one with these operators. Because this statement resolves to either a true or false, we can use that after the if keyword to test that condition. So like above, if that resolves to be true, it runs the code nested within that. So if that condition is met, if the test score is above 40, we're going to print you passed. If not, we're just going to do you failed. Now let's run this. We'll type in a number. Aha, as you can see, it does not work. If you remember from module 2, regardless of what you type into the input method, it will always return a string. And here we have a string, and then we have a bunch of math. And obviously, a string is not the same as a number, so it gives us a type error. And if you remember from module 1, type errors have to do with certain conflicting data types. So in order to resolve this, we have to convert the test score variable to an integer. And we can simply do this by wrapping this with an int, like that. So basically what it does is it gathers the input, and whatever number comes out of the input gets converted to an integer. So now when we run this, we can see 12. So this, yes, I failed, right? Because I got 12. Now let's try, let's say 60. And because that's greater than 40, it says you passed. Okay, so moving on to task 5. This is basically to make a quiz kind of game where you ask a user a question, and based on their answer, you say if that answer is correct or not. So here we have to define a custom function called tfQuiz that takes in 2 parameters. The first one is the question, and the second one is the correct answer. And as you can see, as given in the directions, the answer string should be a capital T or a capital F, indicating true and false respectively. So within this, since we have to grab input from the user, we again use our best friend, which is the input method. And then we're going to call an if statement. This time we're going to use the equal to operator because we're testing if their answer is the exact same as the correct answer. Because these two are both strings, we're not going to get a type error like we had above. So if that's the same, we're simply going to print correct to the console. And if it's not, we're again going to take advantage of the else method to consider the opposite case. So now that we have our custom function defined, let's try out some questions. So when we call this method, we have to pass in 2 different arguments because we define 2 different parameters when we in the function definition. So the first one is going to be a question, and the second one is going to be an answer, and both of these are strings. So let's try this out. So it asks, should you be watching that one last YouTube video? Of course you should. Well, my answer is true, but the answer we're expecting is false. So let's put F to test out that case. It says correct. Let's try out the other case, which is true, or capital T, which indicates true. And you can see that wrong because it's not the correct answer. So let's try this out for a bunch of questions here. And this is where defining custom functions is really powerful because we can replicate the behavior because we can replicate all this behavior with just 1 line of code. And this, yeah, I mean, it's just efficiency basically. So let's put F. Is the earth flat? No, it's not. So let's put an F there, that's correct. Are we living in a computer simulation? Definitely we are. T. And that says correct. So let's try out some other cases. Let's just put, I don't know, T for this. It says wrong. Let's put is the earth flat? True. And you can see that, yeah, it does work as expected. Moving on to task 6. I'm not going to cover this in this video because it's very similar to task 5 in that you create a custom function and you do a variety of checks on that and return an output to the user. Again, if you have any questions on this, feel free to email us. And that, as you can see, concludes our module on conditionals.